So I have an example here for us, first of all, of simplifying the expression, but we're going to follow 2 steps. Now, everybody is required. This is not optional, okay? So what does required mean? Well, it's not optional. What does not optional mean? You have to do it. There's no getting out of it. So there's 2 bullet points. I'm telling you that when we simplify expressions, we are first going to rewrite the expression, changing all subtraction. So if there's any subtraction at all, we're going to change it to add the opposite. Okay? Our second thing we're going to do is we're going to look, see if we need to rearrange so that the like terms are beside each other. We can group them that way. We can box around them and say these guys can be combined because they are like terms. Okay? So here's the example. Here's the algebraic expression. X plus 20 minus 30, I'm right here, plus 5x plus 40. And what's the first thing I did? Harley? I changed the subtraction to add the opposite. How many subtractions were there? How many subtractions? Study the expression on your paper. How many subtractions were there? Sierra? 2. Okay, where are they at? We're up here on this example. Tell me where they're at.
3x and 4. What?
Okay, you're already working number 1. I'm up here on the example. Danny?
1.
There's 1. Okay, where's it at? Okay, this 20 minus 30, so it's right here. Subtract 30. So then I changed it to what? Plus a negative 30. So the subtraction becomes addition, and because 30 is what was being subtracted, the opposite of 30 is what class? Negative 30. So it became plus a negative 30. Then in my next step, I rearranged. Okay, what are the like terms? The x's we can say are alike, and then what? Anybody know what you call those numbers that don't have x's in them? Do you know what you call those? They're called constants. They're called constants. They're a number. They can never change. They are always going to be what they say they are. 5 will be 5. It can't be called something else. Okay? It can have a different name. It just can't be at a different place on the number line. So basically, had the 5x come over, jump ship, and come over here, and where the 20 was, and then I just moved everything over. Do you see that? How the 5x came over here and kind of traded places with the it moved over and said, move over. I want to be with my fellow that's like me. I want to be with that x. And then I put box around the like terms. So making groups of like terms. The constants are like terms, the x's are like terms. Where did I get 6x from in the next line? Where did that come from? Where's 6x come from? Pikey, what do you think? Where did 6x come from?
X plus 5x.
X plus 5x. How do we get that from x plus 5x? How do we get 6x?
Move them both to the front and add them.
Okay, we moved them both to the front. How do we add them? I'm kind of curious about that. How do we add x and 5x together? What do we really actually do? Where does 6 come from? Yeah?
X by itself is 1x, so add the 1x with the 5x.
So this is really a 1x, so we really add 1 plus 5, and we get 6, and x's, when you add them together, they just stay x's. They're just together now. And then 20 plus negative 30 plus 40. What did I do first? What did I do first, Harley?
20 plus negative 30.
Yeah, I did 20 plus negative 30 to get this negative 10 here. And then I added negative 10 and 40 and got 30, right? Okay, so now let's practice one together here. So, anybody want to guide me? What should be the first thing I do? What should be the first move I make here? Hannah? Okay, where at? So instead of it being 20 minus 3x, it'll be what?
20 plus
Okay. What about that 4x plus at the beginning? Should I do anything with that? Does it have to stay with us? Does it have to come along? Yeah, has to come along. Okay. Anything, any other, Derek? Wait,
Change the 3x minus 4 to 3x plus negative.
okay, so this subtraction is gonna change, and the opposite of 4 is negative 4. Okay, that takes care of our add the opposite, right? Everybody do it? Not quite. Okay, now what are we gonna do? We've done the first bullet point. The second bullet point says to do what? Rearrange, right? Rearrange. So, in algebra, who thinks they're more important than the other? The variables or the constants? Who thinks they get to be first, in other words? The variable terms or the constant terms? Algebra. The variable terms think they're most important. So we're going to let the variable terms be at the beginning of our expression, followed by the constants. So anybody want to tell me what I might be able to do here? Gabe? Okay, tell me how to switch them out.
4x plus negative 3x.
Okay, 4x. Bring the negative 3x over beside it.
Plus 20
Okay, plus 20
plus negative 4.
plus negative 4. And so now the like terms are beside each other. That's our goal. So which ones can actually be put together then? Even though I've rearranged them, they're still all one long string, aren't they, Harley?
The x's put together.
Okay, the x's can, so I'll put them in a box together and say, okay, you guys can come together. What do I do with this plus sign right here? What do I do with that? What do I do with that plus sign? Harley?
Put it between the two.
You put it between the two groups, it comes down. And now these guys are constants, that makes them like terms, so they're gonna form a group,
So you take those.
okay?
So you grab
Okay, let's simplify. 4x plus negative 3x. What's 4 plus negative 3? 1? 1, okay. So we have a 1x plus 20 plus negative 4. 20 plus negative 4. You have $20, you get $4, what do you got left?
16.
16, so it's gotta be plus 16. Okay, can we clean that up? In other words, do you think this is how it would look probably in an answer bank? On a test? Probably not. I bet we can clean it up. Anybody know what we could do to this? What means the same thing as this? Ikea?
x minus negative 16.
We don't need to make it minus negative 16, but it does actually, we could do that, but that's not really cleaning up. Now we'd have to clean it up again, so we're not going to change any addition. We're going to instead say, how about we just let that x get rid of its 1? That's what we're going to do, okay? But you are right, we can change addition to subtraction also. Okay, x plus 16 is our final answer. Okay, I want you to do the first step in the next one, on your own. And then you probably tell me what you did. Everybody doing it. The first bullet point.
Do the next one.
Let's leave your paper for a moment. Thanks. Okay, I stole Roman's paper, that's what he did. Anybody want to agree with Roman? Anybody else want to agree with Roman? Okay, we all should. There was one subtraction in that one to change. That minus sign at the beginning is really serving the purpose of what? What is it? What's its role? What's this one? What's this one's role right there? Is that a subtraction sign? What is it? A negative sign, yeah. Okay, so now what will we do in the next one? Go ahead, you do it. Go ahead and do it on your papers. What would you do in the next one? Next line. Can I steal your papers, Miss Hero? Thanks. Thanks, Sierra. Okay. You tell me, you double check, make sure everyone's the way you did so that you don't. Okay, agree with Tyler? You do agree? Okay. Sammy, you agree? Okay. Derek, you agree? Harley, you're agreeing or you're not sure? You're disagreeing. Why do you want to disagree?
Negative 2x.
It's a negative 2x, isn't it? We have to be really careful when we do rearrange that the signs come along with it. So it's okay that she put the 4x first. If you put the negative 2x first, it's okay also. You could have negative 2x plus 4x. That would be okay. But don't forget to bring the negative sign along with the 2x. Okay? And then anything else? So are there a variety of different ways, maybe possibly if I walked around, I would see that you didn't do it exactly like this? Yeah. Maybe somebody has it like this, and you don't necessarily have to write this down, but maybe somebody has it like this. Anybody have it like that? Oh, yeah. Is that wrong? No. No, notice they still kind of, remember, what's that property that allows things to move around, change order in addition? What's it called? No, it starts with a C. Commutative, yeah, it's kind of a funny word, but commutative property says, you know what, you can let them jump wherever they want to, as long as it's all addition, then they can do that. So it's okay that we would have the negative 2x and the 4x trade places. It's okay that we would have the negative 50 and the 75 trade places. Now we will put box around the like pairs, like things. They don't have to be pairs necessarily. So constants are alike, x terms are alike. Okay, how many x's are there when you take a negative 2x and add a 4x to it? Class? 2x. Class, what is a negative 50 plus 75? That's a small class. 25, yeah. Any cleaning up to do in this one? Can anything be ditched? Hannah? No, we don't want to ditch anything in this one. There's no cleaning up to do with this one. That's as good as our answer is going to get, okay? Okay, so I want to make sure that you are understanding how to simplify. If we can't do this, there's a whole lot of stuff in algebra that we're going to get wrong because this is a very important skill. So make sure that you're just following these steps to help you be successful. So again, questions? Okay, now in the next one, this is where we are really actually working with what our learning goal is, finding the value for x that will balance the equation. But we're not going to actually use the algebra tiles on our desk. We're just going to work on paper, okay? So what does it say that is probably an important thing that I wrote on there? Katie? Yeah, you know what, could we circle that right now, please? Because, you got to make sure you read so you don't, question, like, I wonder if these are green tiles or these are red. Or, I wonder if those are tan tiles or they are red. We got to, but it says positive. So that means, in reality, the two X tiles in number 1 would be what color if they were on our desk? Green. And the 8 unit tiles that are on the other side of the scale would be what color if we had them on our desk? Tan. They're all going to be positives, okay? So, in this one, they say we're going to use substitution to find the value. In other words, if I wanted to replace the X tile with something, what could I substitute? What could I replace it with? So anybody have any idea, by looking at this scale, what would one of those X tiles have to represent to keep the scale balanced? What do you think, Katie? 4, and how did you get that? Yeah, across from one of the X tiles. In fact, we have to make sure that they both get the same amount, but across from this one, this X tile, those two could really trade sides because there's an equal sign right here. There's an equal sign. So since each X tile can be paired up with 4 unit tiles on the other side, they really could just jump over and take the place of the X. So what is our X equal to then? It's 4. 4 of these moved over here in place of the X tile. So if I wanted to replace these with 4 unit tiles, we'd have 4 unit tiles equal to 4 unit tiles. If 4 unit tiles equal to 4 unit tiles. Okay? Jake, you do the next one. Make sure you take care of everything there is on that scale. Don't leave anything out. Everything needs to have a part of the equation. Nope, I'm not seeing what, okay, you do it here. Come on, join us. I want arrows. That's going to be your way of substituting. I want arrows. Okay, so your paper here?
Oh, sure.
Thank you very much. Check me out there. Did I do it easy? So, do you guys agree with Derek? This is the kind of support you need to show. Did anything get left out? Is there anything that didn't get accounted for? It said we gave this X tile to these 2 unit tiles. We gave the next X tile to those 2 unit tiles. We gave the next X tile to those 2 unit tiles. We gave the last X tile to those 2 unit tiles. Were any left out? No. So we have exactly the same thing every time, right? So that means our equation is balanced when X is equal to 2. Well, number 3, what's X equal, class? There's only one X tile. What's it equal to? It's equal to 5. What's X equal to in number 4? 1, because each X tile can be paired across to 1 unit tile. Remember this, I mean, did anybody ever look that up and find out if I was right? I called it the fulcrum. Oh, that's a pivot point, what a fulcrum is. Okay, so we gotta figure out what that is. So those arrows are really saying equals. 1 X tile equals 1 unit tile. 1 X tile equals 1 unit tile. 1 X tile equals 1 unit tile. So X equals 1. And what about our last one? What does X equal, class? 3. And this is how we're going to support it. Don't just give me an answer. Use substitution. That's what we're doing right here. We're saying 1 X tile can be substituted with 3 1 tiles, and nothing got left out. In other words, one side looks exactly like the other when you start pairing up parts of it. That's using substitution to help us find the value for x that will help us balance the equation. Questions? Okay, let's go to the back side then. And did I write anything this time? No, so we're gonna write it just so we don't question it. All tiles are positive. I think we'll deal with some negative tiles another day, but today we're dealing with all tiles being positive. Okay, what is different this time? Harley? So there's some of those little unit tiles. I see a unit tile on the left side. Did we ever see a unit tile on the left side on the other page? No. So that kind of throws things off, doesn't it? Could we right now line up an X tile with exactly the same number of unit tiles on the right side? Could we right now draw that arrow and say that arrow means equal? Could we? Danny was shaking her head no. What do you guys think? Carly says no. Sarah says no. I don't think so either. What would we give the first X tile? 1? Because it's in the same row. Then we give the next X tile 2. Would that be the same? No. What would we say X is equal to? Is it equal to 1 or is it equal to 2? It's not, yeah, it can't be both. It can only be equal to one thing within this equation. So what do you think we're going to do? What do you think we could do? Think of this. This is a scale. There's this equal sign right here. This means equals. When we see this right here, it's saying, you know what? That side is equal to this side. They're balanced right now. This is that teeter-totter, that the same weight is on each side. So what can we do to figure out what X is, but yet keep the scale balanced, keep the teeter-totter balanced, keep the equation balanced? Any ideas? No ideas? What if you were on a teeter-totter with somebody that was 5 pounds lighter than you? Would you guys be able to equal it out? No, because they're lighter, right? Okay. But then they also decided, well, if we, I really want us to have a balanced teeter-totter today, so they grab a 5-pound weight and they have that in one hand. So now do they weigh the same as you? Okay. What if they get tired of holding it and you're being kind of crazy on the teeter-totter and they need both hands to hang onto the handle, so they throw that 5-pound weight to the ground? Is the teeter-totter still balanced? No. But if the person on the other end could throw down 5 pounds, they could maybe their shoes weigh 5 pounds and they could ditch those. Maybe then, would that be enough? They could ditch their shoes, you could ditch the 5-pound weight and everything would be well. Okay? So what do you think we could do here? Don't look at me, I don't have the answer written on my face. Look at your paper. Figure it out. What do you think we could do to figure out what X would have to be equal to? I'm trying to learn tough love right now. I'm having to take care of my sick dad, and so I'm trying to be tough with you guys too. I'm trying to learn tough love. Don't always just give them what they want. Give them the answer. Make them think. Oh. Anybody come up with it yet? Pardon? Your brain hurts. Just over this. Oof. Anybody? Would be the genius of the day. You don't even want to try something? Even if it's not right, you just don't even want to try something? Because what's going to happen? Is the second floor going to fall into first if you're wrong, or what? Tell me something to try. When I give it away, you're gonna be like, oh, seriously? Yes, Danny? Add one of the tiles on the left side to one of the tiles on the right side? What do you think, Claudia? And Danny says, could we just add? She says, this is kind of how she pointed to me. She says, could we just add this and this? Right? Is that kind of what she said? Yeah. Harley, what do you think? You've got to add,
Just that one.
ditch that one, and then add another one.
Yeah.
You guys are kind of close. Remember I said, if you drop that 5-pound weight and the other person dropped their 5-pound shoes off their feet, that would be heavy shoes, but they dropped their 5-pound shoes off their feet, would the teeter-totter stay balanced? If he was balanced before you dropped those things? Yes, because they each weigh 5 pounds. So if together with these shoes and this 5-pound weight, the weight on the teeter-totter equaled 140 pounds on each end, dropping 5 off of this end and 5 off of the other, how much would be on the teeter-totter now? 135 and 135. So it would still be balanced, wouldn't it? And we dropped 5 pounds off of each end when it was balanced at 140. So could we just do this? Drop, drop. Could we do that? Would it still be balanced now? If we took 1 off of each side, would it still be balanced? Yeah, I need to convince you that yes, it would. A unit tile is a unit tile. They're the same. If I take 1 off of one side and then take 1 off of the other, all is well. Everything's okay. Well, now, do you think we could do what we were doing on the front side? Would this unit, this X tile, pair up with one of those, and this one pair up with the other one, and we could say X equals what? 1. Hang on. X equals 1. Each X tile is paired up with 1 unit tile. Okay, now I bet you're feeling more genius-like, right? Number 2. What do you think we could do on this one? What do you think we could do this one, Danny? One what? Okay, which kind of tile? An X tile or a unit tile? A unit tile? Is that what you said? Yes? No? Did you say unit tile? Oh, yes. Okay. Well, if I'm going to cancel out a unit tile, I'm going to be able to cancel one out on each side. Do I have any unit tiles over here, you guys? No, so I can't cancel out a unit tile because both sides don't have one. You got to both have one. So let's try something else. Harley?
Take an X tile.
Take an X tile from both sides. You're going to take the same amount from each side. So we're going to take this X tile and this X tile, 1 from each side because we need to stay balanced. Okay? Now, do you think we've done enough? Can we do our substitution thing, our arrow thing now? Yeah. Okay? So we have this X tile that could line up with how many unit tiles? 4. As long as the other one can also. Can it? We could say what X is equal to. What does X equal? It equals 4. Okay, you guys are so smart now. You're going to do the next one on your own. Go. Cancel if you need to. And then substitute using the arrows. And then I'll take a brave volunteer to come up and do it at the board. We're going to use up your homework time. Anybody want to agree, disagree? Question? What do you think? Where's your arrow there? Wait. You got any arrows showing the substitution, showing the equality? Come on up with some arrows to convince us that x is equal to 3. You gotta do both things. You just did the canceling. Okay, thank you. Okay, so he put an arrow from x over to the other x value. He says they're equal to each other. Do you agree with that? They're equal to each other? Yeah, and they're the same. Same equals same. And then down on the bottom he says, this x tile over here is equal to those 3 x tiles that were left after I canceled. Do you agree with that? So what could Wade have done that maybe you did and we all could do? Because Wade's not wrong, but he really could have done one more thing. Anybody want to tell us what that is? Because right now, what has arrows to each other, they don't look alike, do they? An x tile arrow to another x tile, an x tile arrow to 3 unit tiles, they don't look alike. So are you sure we're convinced that that's okay? Oh my goodness. Anybody please, I need help. Tyler? Yeah, take these x tiles there's one of on each side and cross them up. One on each side, because yes, they are the same, so we can do that. That's gonna take care of this arrow thing that we got going on here, because we can cancel one from each side. And then notice now, we can say, oh, now this x tile can be matched up with those 3 unit tiles, and now I don't have anything else that doesn't look like it. And we're also going to put an x here. We're going to say x equals 3, not just equals 3. Okay? Okay, now we got this. Here's what we need to do. We need to look at the left side and see if there's anything that might be useful to get rid of right away. Harley? Oh, there's 2 x tiles on each side. She says, you know what? Why don't you get rid of those guys? If you can take 2 off of one side and 2 off of the other, get rid of them. They're just extra that we don't need on them. Now what else can we do? Anything else? Ikea? Derek? Haley? Tyler? One on each side? Yeah, cross out a unit tile on each side. It doesn't matter which one I cross out on that side? No, as long as I just get rid of one of them, because I got rid of one on the other side, I gotta get rid of one on this side. So now I have 1 x tile left, and I should hopefully be able to pair it up with something over on the other side. What can I pair it up with? How many unit tiles? 5. X equals 5. Do I need to see all the steps from you? Yeah. Show your canceling, show your arrows going on, saying this over here is the same as that over there. Okay. How many x tiles can we cross out on both sides in this next one? 2. Yep, 2. These are going to go. How many unit tiles can we cross out? None. We don't have any unit tiles over on the left side, do we? So we're going to say, okay, well, let's see if our substitution is going to work then here. Do all of those substitutions look alike? So what does x equal? 3. X equals 3. Okay.
Today is recycling day, so we'd like to have someone from each classroom